In this second example, we're going to be looking at the inverse variation. Now, this example actually shows how creative maths can be in regards to, we're talking about wavelengths. This is a symbol called lambda, and that normally refers to wavelength. It says the wavelength lambda in meters of a musical tone is inversely proportional to its frequency, f, in vibrations per second. Write this algebraically. So as it's inversely proportional, that means that lambda is going to be proportional to 1 over the frequency. So using the equation from before, that means that lambda is going to be equal to k over f. For part B, it asks us, it says the frequency of middle C is about 260 seconds to the negative 1. So that means 260 vibrations per second. And its wavelength is about 1.319 meters. Find the constant of proportionality. So as k is the constant of proportionality, I'm going to sub these values in and we'll see what we get. We've got 1.319 is the wavelength, that's the lambda, so we're going to have that there. And then for our f, it's 260, so we're going to have k over 260. Now, we want to get k by itself, so we're going to multiply 260 on both sides. So by doing that, we're going to get k is equal to 342.94. Next, we have C. It says, find the wavelength of a sound wave with frequency 440 vibrations per second. So we'll just replace 440 in, but we know that k is this value, so that means that the original equation is going to look like this. Lambda is equal to 342.94 over f. So as it's talking about frequency, we're going to be replacing this f. So we'll do that now. We're going to have 342.94 over 440. So typing that into our calculator, we get that lambda is equal to 0.779. That answers part C. Part D, find the frequency of a sound wave with wavelength 1 meter. So if the wavelength is 1 meter, that means we're replacing lambda with 1 and keeping f as it is up here. So that is 1 is equal to 342.94 over f. That's our 1. So with a rearrangement, we'll multiply f by both sides, so we get f is equal to 342.94. So that's our answer. The frequency will be 342.94. Now E, it's asking us to actually think about what we've done. So it says, what is the approximate speed of sound in air and why? Well, if we were talking about the sound wave with a length of 1 meter, that means that the sound is moving at about, if we round this up, it's at about 343 meters per second. So that's assuming that if we're using 343 waves or vibrations per second of a size 1 meter. So that is our approximate speed. We're approximate because we've rounded up to a whole number, and that's our reason why.